Do not adjust your television sets. I had some technical difficulties with the second half of this video, so I had to re-record it when I got home. What we just covered previously were the basic algebraic properties of equality, so the math operations that you have been doing for years. These next few that you see here, I would call level 2 because they're a little bit more advanced, and some of them may be used much more frequently than others, but they're kind of additional tools that can help you to solve algebraic problems. So this first one is called the substitution property, and that says if A equals B, if two things equal each other, then A can be substituted for B in any equation or expression. And we can do that to help us simplify equations or expressions, or maybe combine like terms. So that's something that could be very helpful for us. For example, if I said that x equals 2, and then we had this expression 3x plus 11, we can't do a whole lot with that right now unless we decide, or unless we use the skill of being able to substitute that term where we see the other one. So then instead of 3x plus 11, we could rewrite it as 3 and then put 2 instead plus 11. And this is nicer for us because now we can simplify some of these things. 3 times 2 is 6. 6 plus 11 is 17. So when we can substitute in a term somewhere else, it can help further our process to a solution. The next term here, the reflexive property, think of that like a mirror. Like when you see your reflection, so just anything equals itself. A equals A. So if I have the number 5, it equals 5. 5 is 5. The symmetric property is slightly different and more useful. I don't remember many situations off the top of my head when I use the reflexive property, but I use the symmetric property a little bit. So what the symmetric property says is if A equals B, then B equals A. So you can like flip them. So if I tell you that x equals 100, then I can also say 100 equals x. So you can just flip everything over, because if it equals itself, one thing equals the other, then the other equals that. And the last one I want to cover right here is called the transitive property. This one is really, really helpful. The transitive property says if A equals B and B equals C, then A equals C. We can think of this, I'm going to really color code this, so we'll start with red. If A equals B, I'll put B in blue because there's a little bit of alliteration. And then I have B equals C, and I'll make C in green. Nope, because there's green right above it, right there. If I have A equals B and B equals C, well, then I can kind of smush them all together. A equals B, which equals C. A equals B equals C, and then I'm just going to cut out the middle term there. So A equals C. That one is a really difficult term, property to understand in the abstract like this. But if we put this one to use, this transitive property is very, very helpful. So I would probably star this one, because the transitive property and substitution, those two especially, are really, really important, and you will use them through the whole rest of the year. Let's try let's see if I can do my hotkey. There we go. Let's try a couple examples. What is the name of the property that justifies, there's that word again. What is the name of the property that justifies going from the top statement to the bottom statement? So the top statement for number 1 here is 7x plus 3 equals 24. And the bottom statement is 7x equals 21. Well, what happened on the left side? We just got rid of that plus 3, so we did that. And 24 going down to 21, oh, that's also subtracting 3. So the property we used was subtraction. Number 2 is a little bit more difficult, as it tends to be. We are given that x equals 5 and 5 equals z. That's our top statement. And then our bottom statement is x equals z. Well, we got a lot of things going on. So I am going to try to separate things, kind of color code it. We have x here and there. We have this number 5 in a different color. It's number 5 here and there. And then we have this other term, z, here and there. So it appears as though we have x equals 5 and 5 equals z. So when we are rewriting it like this, which you don't have to do because we have this really helpful property, the transitive property. Oh, my pen glitched a little bit, so it didn't. Transitive, T-I-V. The transitive property says that if we have that top line, x equals 5 and 5 equals z, then we can just put the first and the third thing equal to each other. You also could argue that that maybe was the substitution property. So that is also correct, but I would say transitive property. And that's how we use these properties.